Hello and welcome to Physics Talk. Our first lesson is kinematics. For this course, I am assuming that you have a basic understanding of vector algebra and calculus. If you have any problem in these topics, please contact me. I'll make a separate video on these. So, when we say kinematics, now what is kinematics? We need to know first. See, classical mechanics. See, when we say classical mechanics, or specifically Newtonian mechanics. It has two parts. Okay, so first part is called kinematics, and the second part is called dynamics. So what is kinematics? Kinematics tells us the position, velocity and acceleration. So we can find out the position, velocity and acceleration with respect to time. There are many more things like angular position and etc., but we will study them later on. In dynamics, we study force, momentum, etc. Now, kinematics tells us how far the body has moved in time t and what is its acceleration and velocity and other things as I have mentioned. Dynamics tells us that if the body is moving, then what is the reason behind it? Okay, why is it moving like that? Why is it moving at that particular acceleration, at that particular velocity? So dynamics tells us that. So here we are studying kinematics. So first we need to understand what is rest and motion. Okay, so first topic is rest and motion. Okay, now I'll give you an example regarding this. Like, this is moon and there are two people, person A and person B on moon. Suppose we have moved into such technological era that we have built a civilization on moon and there are people on moon, living on moon, and we have two people there. Suppose the person A is sitting down, so okay, it's sitting on a bench, so A is at rest. We can say A is at rest, but with respect to whom? B will say that A is at rest because B is also on the moon. So it is B can easily say C that A is at rest. Okay, but suppose this is Earth. Okay, this is the moon. This is Earth, and we have another person on Earth. Now we know this person is C. We know that moon revolves around the Earth. Okay, in the orbit. Okay, so this is actually moving around this Earth. So according to this person C, this person is not at rest. Okay, according to this C, A is not at rest. So here we can easily see that rest and motion are relative concepts. They are not absolute. We can say that rest and motion are relative, not absolute. Okay, so here comes the concept of frame of reference. Now what is a frame of reference? Suppose we have a coordinate axis. Okay, this is y, this is x, and this is z. This is your origin. Now if you have a person A here, okay, any random particle or a person, so it has some relative position with respect to this coordinate axis. We call this position vector. This is called position vector. I hope you know vector quantities. Okay, we call this vector r. This is called position vector of the particle or the person. Here the person. Okay, so this is the frame of reference with respect to, suppose this coordinate x, y and z, we call this S frame of reference. So with respect to this S frame of reference, it has position vector r. Okay, now if we consider another frame of reference here, okay, suppose x dash, y dash and z dash. Okay, okay, so with respect to this frame of reference, it will have some another position vector, not this. It will have r dash with respect to this. Suppose this particle A is here with respect to this frame of reference S dash. Okay, so this is r dash vector. Okay, so you can see that frames with respect to frames of reference, the position of the particle can change. Okay, now as far as rest and motion, we can also say that suppose this is moving, this S dash frame is moving with some velocity v. We'll come to what is velocity, okay, later on. It is, you can consider it for now as the speed with which it is, this frame of reference is moving towards positive x direction. So now a person who is in this frame of reference can say that A is not at rest, A is in motion, but person who is on this frame of reference can say that A is at rest. So we can see that rest and motion are relative again, as the example I gave you in case of earth and moon. Okay, so this was all about rest and motion. So next concept, is about distance and displacement. So distance and displacement. Okay, so now at first glance you can say that distance and displacement are same, but are they? Let's take an example. Suppose this is our axis. Okay, this is x, this is y. Suppose, okay, this is position A. Now a person is moving from position A to position B and it has taken this path via C. Okay, so what is the distance? Here distance will be the total length of ACB, this arc. Okay, this path, total length of ACB. Okay, but what is the displacement? Displacement is actually the shortest distance from one point to another. Now here if we join these two, okay, so this will be your displacement. Okay, it is the straightest path and this will be the displacement. Now displacement is a vector quantity. Displacement is a vector quantity, so it has magnitude and direction. Okay, so it's a vector quantity and its unit is meter. Distance is a scalar quantity, it has the same unit, okay, meter. Now let's take an example of the concept that I mentioned you. Okay, so this is a question. Suppose a person is at A and there is another point B, okay, and a person moves from A to B via this semicircle. This is a semicircle. Sorry, my drawing is not so good. Okay, This is a semicircle of radius, some radius r. Okay, this is a straight line. This is a straight line. Now this is a semicircle. Now what is distance and displacement here? Please take a moment to solve this question. Pause this video and solve this question. Okay. So what is the distance here? Distance is the length of this path. So we know the length of this path is nothing but pi into r. How is this? Pi r. This is the circumference of this circle divided by 2. Okay. What is the displacement? Displacement is a straight line joining these two, and here it is 2r. So we can see that displacement and distance are different in magnitude as well. Okay, they can be same. It's not that they cannot be same. Okay, suppose the person would have taken this path, not this path, then your distance was also 2r and displacement was also 2r. Okay, so this was all about distance and displacement. Okay, now let's move on to next topic is average speed and instantaneous speed. Okay, so what is average speed? V average is nothing but change in distance s2 minus s1, okay, by change in time t2 minus t1. We can say that this is delta s by delta t. Okay, so this is V average. What is s2 and what is s1? S2 is the final position and s1 is the initial position. T2 is the final time at what we reach S2, and T1 is the time at what we reach S1. Okay, so this is your V average. Okay, now what is instantaneous speed? V instantaneous. Okay, now I am claiming that V instantaneous is this quantity. Okay, if we put a limit delta t tends to 0 on delta s by delta t, okay, this will give us ds by dt. I hope you know what is ds by dt. This is the derivative of s with respect to t. Okay, now how am I claiming this? Okay, let's take an example. We all know that distance is a function of time. Okay, distance is a function of time. At what time you are at what position, that gives us the distance traveled. Okay, so let's take this function to be a t cube plus b t plus c. Okay, now what is s? This was s of t. Okay, now what is s of t plus dt? This is a t plus dt whole cube plus b t plus dt plus c. Now if we solve this, we will get something like this: a t cube plus bt plus c plus 3a t square delta t plus b delta t plus 3a t delta t square plus a delta t cube. Okay, now what is delta s here? Delta s is s of t plus dt minus s of t. Okay, delta is what? The distance traveled at time t plus dt minus the distance traveled at time t. Okay, so if we subtract this from this, we can see that this gets cancelled, these three terms. So this is nothing but 3a t square delta t plus b delta t plus 3a t delta t square plus a delta t cube. Okay, now if we take out delta t from here to this side, or if we divide the both sides by delta t, okay, we will get 3at square plus b plus 3at delta t delta t, yes, 380 delta t plus a delta t square. Okay, now if we put limit delta t tends to 0 at this, so in this expression, what is the expression, final expression, if delta t tends to 0? So this becomes 0, this becomes 0, and this is nothing but 3at square plus b. This is what is this? This is nothing but ds by dt. Okay, so I have proved that v instantaneous is delta t, limit delta t tends to 0, delta s by delta t, which is nothing but ds by dt. Okay, now I just mentioned you that v instantaneous is delta t by delta s. Now what is the, sorry, delta s by delta ds by dt. Now what is the meaning of this, physical meaning of this? Let's see. Okay, suppose this is your s versus t graph. This was your path. Okay, now what is v average? V average is you take this point 1 and this is 2. Okay, you join it by a straight line and you find out the slope of the straight line. Here the slope is what? You can see it is, see, this is s1, this is s2, this is t1, and this is t2. So v average is what? S2 minus s1 by t2 minus t1. So this is your v average. This is nothing but the slope of this curve. Okay, so suppose we make this point more closer, this point more closer. Okay, so it will be something like this. Okay, now we have made this closer, so you can see it's something like this. Now the v average is, we can find out the v average in the same method. Now we make this point more closer and we make it as close as possible to t1. Okay, so what happens? This becomes almost like a point, not 2 points. Okay, so 2 points almost overlap. Okay, now in this case, when you draw this line, this is will be nothing but tangent to this curve. Okay, now if you find the slope of this tangent, this will give you the instantaneous velocity, and we know from mathematics that slope of this tangent is ds by dt. This is your v instantaneous. Okay, got it? Now I have another concept. Okay, let's say v is equal to ds by dt. Now we can write v dt is equal to ds. Just I have multiplied dt with v. Okay, now if we integrate this expression from suppose t1 to t2, and this is suppose 0 to s. Okay, so what we get, s is equal to v dt integration from t1 to t2. Now let us understand this from the graph of v versus t. Suppose this is vt curve. Okay, vt curve, just like we had st curve, we will have a vt curve. So this is your v versus t curve. Okay, suppose we write that this is dt. Okay, this is dt and this will be v, this is v. Okay, the integration, sorry, this v into dt is this area. Okay, now integration means actually, see, integration means summation, okay, of discrete quantities. in case of, sorry, integration means summation in case of discrete quantities. Sorry, this should be continuous quantities. Okay. Now, summation means what? From t is equal to t1 to t is equal to t2. We take all these small areas and we add them up. Okay. So what is addition of these small areas will give us? This will give us area under the curve. Therefore, we can say that your S is equal to area under VT curve. Okay. Now, this is very important. This will help you to solve a few questions. Let's say I have a question like this, that this is your curve. Okay, this is V versus T, and it is something like this. This is 3 seconds and this is 6. Okay. Now you need to find the distance. So here distance, we know that distance is area under VT curve. So here area is what? This is the area. So the area is, this is nothing but a triangle. So it's half into base into height. Base is equal to 3 and height is equal to 6. So this is 3 into 6, which will give us 9 meters. Okay. I hope you have understood this. Now let's move on to next topic, which is average velocity and instantaneous velocity. Average and instantaneous velocities. Okay. So next topic is average and instantaneous velocity. See, this is same as average and instantaneous speeds. Okay. Now, nothing but V average is equal to some displacement by change in time. Okay. See, the distance was replaced, distance in this case is replaced by displacement. So this is average velocity is what? This is a vector quantity. Now how do we write this? AB. AB is what? Displacement from A to B. Okay. Suppose this is X, this is Y. Okay. Now this is A and this is B. So this vector will give you AB vector. Okay. This is the position vector. Suppose RA of A, and this is the position vector of B, RB. Okay. Now what is AB vector? From the law of vector addition, we can say that AB vector is nothing but RB vector minus RA vector. From this diagram, we can say that. Therefore, V average is what? It's RB minus RA. RB vector minus RA vector by change in time. Okay. So this is what? Delta R by delta T. We can write it like this. If you put limit delta T tends to 0 in delta R by delta T, this will give you dr by dt. Okay. This is nothing but V instantaneous. Got it? Now, what is the unit of velocity? Unit of velocity or speed. Can say it's distance per unit time. So it has to be meters per second. Okay. Now we have another concept, acceleration. So here also we have the concept of average acceleration and instantaneous acceleration. Okay, it's the same thing as velocity, but acceleration, V average, is change in velocity by change in time. Okay, if we put limit delta T tends to 0 in this This will give you dv by dt, and this is a instantaneous. Okay, so acceleration is what? Change in velocity per change in time. Okay, what is the unit of acceleration? So acceleration is velocity per second. So velocity is what? Meters per second. So unit of acceleration will be meters per second square. So I hope you have got everything. Now we will move into motion in straight line, but I've made this video too long, so we will move it into in the next video. So thank you for your time and keep practicing.